physics chapter 2, section C, equations of motion. These are three kinematic equations we have to study. Now there are various ways to derive them. The graphical method, mark it as read, not important. We would rather use the alternative method or algebraic method. By definition, acceleration is a change in velocity upon time, so we already know that v is equal to u plus at. Now for Roman number 2, we find this value of s, which I had explained earlier on board. We substitute the value of v from equation 1 in this equation. We solve and we get a second kinematic equation. We do a similar treatment in Roman number 3, but this time we don't substitute the value of v, we substitute the value of t from this equation number 1, and we get the third kinematic equation. Notice that if the initial velocity is 0, the equations become simpler. And if acceleration is negative, instead of plus sign, we can put a negative sign. So we'll do numericals based on these in another class. By definition, a is equal to v minus u upon t. So by cross multiplication, we get v is equal to u plus at. That is the first kinematic equation. Now we will derive two more equations. Now, in order to calculate the total distance, we use the formula average velocity into time. Now, understand that these equations are very useful when the motion has non-uniform velocity. If it's a uniform velocity, then we use a normal formula. Speed is equal to distance upon time. But if it is a non-uniform velocity, then things become more complicated. The total distance is average velocity multiplied by the time, because average velocity, by definition, is total distance upon time. And here, by distance, I mean displacement, because we are considering motion in one dimension. No change in direction here. So, average velocity is nothing but initial plus final velocity upon 2. Assuming that the acceleration is uniform. So, this will work only if the acceleration is uniform. These equations. Now, instead of v, what if I substitute u plus at from equation 1? So, I get 2u plus at upon 2 into t. Split the fraction, so 2u upon 2, 2 cancelled, and t is multiplied with both the terms, distributive multiplication when you open the brackets. So finally you get ut plus half at squared. This is the second kinematical equation of motion. This was the first one. Next. Now again, in this equation, which we had got here, instead of substituting the value of v, let's substitute the value of t. So from the first kinematic equation, cross multiply, rearrange the terms to get t alone. U becomes minus u, a goes down, so t. And this value of t substitute out here. So I'm getting the numerator as a plus b, a minus b. That's a squared minus b squared. And then 2a goes up, minus u squared shifts and becomes plus u squared. And so you get the third equation, v squared is equal to u squared plus 2a. So these are the three equations we shall use in numericals. Now when to use which one will depend on the data which is given. So when we'll practice a lot, we'll get the hang of these equations. And yes, this derivation can also be asked in exam. Not the entire one, either this derivation or this one. So if you're deriving this one, no need for this part. We'll just introduce the variables, get this equation, and then start from here. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.